Hi, this is Max again, NG7M on the camera here, and this video was spurred on by some posts after I made my last tutorial on setting up FSK with a COM port MMTTY. I made a really long video. It's approaches 2 hours. It goes into the details of setting up a K3, K3S to use internal FSK, where the K3, K3S is generating the tones. So that spurred on the inevitable, I wasn't surprised, discussion about the timings on FSK as compared to AFSK. And so there's kind of two mindsets there. A lot of the stuff I found is from literally like 8 years ago, and so I've never had a problem keying FSK off of a FTDI USB COM port, and so I really wanted to see what the numbers looked like. So a couple questions on my, not necessarily on the video, but it brought up that question of you're going to have a better signal, especially at weak signals, if you use AFSK using a sound card, because the clocks in a sound card are dedicated, so you're going to get that precision timing, and as compared to FSK, again off of a USB FTDI COM port, where you're I think guys have called it bit banging, right? So you've got external FSK64, the DLL working in conjunction, and I'm just sticking with MMTTY kind of as the baseline as far as RTTY generation goes. And so that's what this video is about. We're going to get some real numbers. I've got a couple cameras here. There's a couple segments here which I've already taken video of the hardware setup, and it was easier to do with an iPhone, so we'll get to that. So let me just show you the screen here, and I may duplicate some of the details here, but we've got, make me a little smaller here. So this is a camera that's on the scope here, and let's see, I might be giving away some details there. Let's turn that off, clear it, and I'm going to turn off the scope for now, and I just want to show you what I've got going on the computer here. So right now I've got N1MM. The next segment will show you the hardware, the USB serial 8-port serial port that I have hooked up, and talk about the computer a little bit. So there's a fair amount of load here, because I'm the main screen here you're seeing right here, where you're seeing the mouse move around, is it's a 4K monitor, and I'm recording in 4K using OBS Studio. It's a free video recording software. So the CPU is an Intel Coffee Lake. It's their latest generation. It's the 8700K running at stock speeds, and you can see it's with the 6 physical cores and then 12 threads. The other 6 threads are it's called hyper-threading, and really all that hyper-threading does is it keeps the 6 physical cores as busy as possible. And so I thought I'd mention that. Probably the best way to describe hyper-threading, again, 6 physical cores, 12 threads. The hyper-threading is like eating donuts. If you are eating donuts and you have to, every time you finish a donut, you have to reach out, grab a donut, bring it back up to your mouth, and start eating the donut again. That time between finding the next donut and getting it up to your mouth, that's without hyper-threading. Hyper-threading constantly has another donut ready. As soon as you finish one, you can start chewing on the next donut in your mouth. That's the best explanation I've heard. So hyper-threading with Intel. So the CPU right now, you can see, is bouncing around 40%, and this is a high-end CPU. It's not a slacker. And so its boost is at 4.3 gigahertz right now. And I've got a Spectrum scope going. I've got Win4K3 Suite on the other monitor. Let's see if I can show that. So the top right display, if I turn that on, Well, maybe I won't because it's just going to get a mirror effect. But I've got WinForm K3 Suite right here running, and it's polling the K3 rather rapidly, and then it's also generating 3 virtual K3 feeds that are getting fed to, I tried to load this down. I tried to make it a little more real world. So those virtual K3 feeds using COM0COM virtual serial ports, I'm feeding my SPE 2K-FA, and so I tuned, and so the focus came back there. So as I tune the radio, I mean, just showing you the demo here. So the 2K-FA software, as you can see as I'm tuning, it's tracking it so the amplifier knows exactly where everything's at. And the amplifier is actually pulling the K3 data from that virtual serial port. Maybe a little too much information, but at least, it's a little more real world here, rather. And then I've got PST rotor going with a couple SDA 100s. I've got a big IR and a DB18. So there's a couple more serial ports there that are going. All the serial activity is on that one 8-port card. And for the demo here, we're going to obviously do EXTFSK64, latest version I could find, 2.0 E, with the latest version of MMTTY, which is 1.7. And then for the flip side, we're going to compare against, I'll be running the TinyFSK, and that's on a Arduino card, and I'll show that in the next video segment. But there you have, so in effect, you're going to have that Arduino is a dedicated CPU, which is timing, the on-off signal to key FSK. And so the timings we're going to focus in on is the standard, I believe it's the shift. I always get mixed up on that. But anyway, it's the standard, it should be exactly 22 milliseconds at 45.45 baud. And then if I remember, I'll kick it up to 75 baud, and then I think you're right around 13.4, 13.5 baud. So what you're seeing right here is a serial terminal that's connected to the Arduino. It's 9600 baud, and you set up MMTTY, which I'm not going to control the Arduino via MMTTY because I can just do it here. You can change the baud rate, look at the current settings, that type of thing. So the current config, right, is baud 45.45, but in the terminal here will be, hopefully I'm not covering me up there. Let's see. Yeah, so the terminal, you should be able to see this here, and I could zoom in, I guess, if I've got that going. Yeah, I mean, this is like crazy big. So the terminal here, we're sending down characters right to the TinyFSK, which is running on the Arduino. If I send the open, so you control transmit and receive on the Arduino with the square brackets. And so I'll be sending down the left square bracket, which is going to kick it into the Diddle, and then we'll be able to measure the timings there as compared to MMTTY with external FSK 64, the latest version of that too, which I already mentioned. So that's how that's going to work. So let me stop this segment here. We'll get back out, and I'll segue into just a handheld video with the iPhone where I show you some of the hardware and the probes and the external thing, because I didn't have another webcam going here. So stand by for that, and then after that we'll actually get to the fun part where we take a look at the timings based upon the load of the computer. All right, see you in a second. This segment is to show you the hardware for the timing test, and it was just easier with my iPhone. So as I probably mentioned in the first segment, the main computer we're going to be demoing on it's a high-end computer. It's the latest Intel generation i7, which is a true 6-core, and that's up here. I'm gonna show my rat's nest here on the station. And normally this would be an overkill for ham radio, but it's an 8700K setup. It's got a Z370 motherboard, and it's very performance for the consumer grade CPU. It's about the fastest single thread performance you can get. So what I wanted to show you, the serial connection, I'm using if you can see this down in here, this is a VSCOM 8-port USB 2.0 box, and I've got a lot of activity going on it. So I've got several things going on as far as the K3 hooked up with WinFor K3 Suite, and then it has 3 virtual K3s going off of it, and then I've got feeds going to SDA100 controllers. Suffice it to say, there's a fair amount of serial activity going on there. I mean, not crazy compared to today's standards, but this cable right here, it's on port number 7, and these are just labeled 1 through 8 here. By the way, these are really nice boxes. If you take your time, you can find them on eBay. They're true FTDI chipsets. So a single USB connection into the back of the Z370 here, and I think I've got the serial card coming right off the motherboard. It's one of the USB 2.0s off the motherboard down here. I've got a panel. So I mean, that gives you an idea on that hardware, and I wanted you to see too that it's going to be loaded down a fair amount, and I'll talk about that more. Right now, you've got a fair amount of CPU going because I've got OBS Studio going up here on this other monitor. So I'll be recording in 4K. So this is a 32-inch 4K monitor. So everything that will be going I'll have N1MM going, the cluster feeds going. It's a Thursday evening. I think the sprint's on, so there's a little RTTY activity. I've got the UDP feed out of WinFor K3 Suite going into the Spectrum display for N1MM. So we're dealing with a high-end setup here, but it's going to be loaded down. We're taking advantage of those 12 threads, 6 true cores. I'll talk about that probably in the other segments. But for the FSK test coming off the serial port, again, port number 7 here, this beige cable coming out. It's just coming over here. Here's my high-tech setup coming over here, and so I'm just taking the TXD and ground off of the header there, going into the probe here. The probes are at 10x to a Rigol. I never have been able to figure out exactly how you say that, and you'll see more of this in the other segments. It's 1104Z, and I think the max mega samples per second is 250, and we'll show that a little later on too. So got another webcam here for that screen, and then my main webcam. And then for the second channel, this is actually the second channel, so we'll have the as far as the scope is concerned. And then the first channel, I'm using we can get in here. So we're using TinyFSK, and this is an Arduino Nano. It's a V31. I don't know if it's a knockoff or whatever. Anyway, it's got TinyFSK on it. And so the other probe, again, 10x probe, is coming off the ports on the Arduino that are it's supplying 5 volts, similar to what the serial port would do. And so, I mean, what we're going to be sampling here, obviously, is the voltage on, voltage off, and we'll be looking for the 22 milliseconds at 45 baud, and then I'll see if I remember to do 75 baud. But we should get some pretty good information here. And then, I mean, because a lot of guys, you're not going to have this type of a PC. I mean, this is pretty high-end stuff, more commonplace, latest and greatest Intel, Coffee Lake 8700K. Oh, it's running at clock speeds. I have not overclocked it. By the way, these overclock great. You can run all 6 cores at 5.2 gigahertz, especially on like a water loop setup like I have here. I threw in another computer here. This is an older Generation 3. This is about 5 or 6 year old i7 laptop that has true 4 cores and 8 threads. And at the end, I just want to show it doing the FSK off of the external FSK64 DLL for MMTTY. So we kind of have a little more of a real-world comparison here on that computer. So I'll hook that up. Anyway, that's the hardware, and then we'll get into the video again. I think I've got it covered there, everything I wanted to show hardware-wise beforehand. Alright, so we'll segue into the next segment here where we actually do the measurements. Stand by. Alright, so we're back from the kind of the hardware description there. Hopefully that wasn't too much information. So now I'm going to start with TinyFSK. So we'll start off with the dedicated controller. In effect, right, you get this dedicated CPU, because that's the big dilemma in the past. There's been a lot of validation, in fact, on slower computers or lower core number of computers especially, to where you get some jitter. And I should have mentioned that early on. This whole video is to show and demonstrate the jitter difference between something like TinyFSK or like the old CAM controllers, you know, where you offload the timing to a dedicated CPU. And so I'll start with TinyFSK on the scope. So let's make me small here. We'll try to get down to where the tire hits the road. And I'm going to turn on the camera that's on the scope. I'm going to make that fairly big. And right next to me here. Let's see. So again, this is a Rigol DS1104Z. And let's see, right now, I think I've got it on the second channel right now. The first channel, so just so you know, as you're looking at this, the yellow is the first channel, which I mentioned in the video on the hardware, is the Arduino with TinyFSK, and it will be the trace that you see at the top here. And I can't trigger, I mean, I don't use this scope a lot, so if I can trigger on two different channels at the same time, I clearly didn't look it up in the manual, so we're just going to trigger on one signal at a time. The yellow trace will be TinyFSK with the dedicated CPU on the Arduino. It's the Arduino Nano. And then when we're done looking at that, and we'll do different, in effect, we'll you know, start out where each segment on the scope is you know, 10 or 5 milliseconds, and we'll get down to like 2 milliseconds. And the samples, the mega samples per second, obviously is going to change as we change the resolution of each segment on the scope on the horizontal axis where the timing is. So the vertical axis, obviously, this is pretty boring for you guys, is the voltage, and so we're just concerned about the timing when the voltage comes on, when it goes off, timing that interval. So I need to, let's switch over to channel 1 here, and there's my big fat fingers there. And so I'm listening to channel 1. I got to set the trigger to channel 1. Let's see. Bear with me a second. So now we're on. There we go. So you saw that. So you got the trigger up here, and so we're going to kick. Now let me come back to TinyFSK, just so you can kind of see it over here on the right side. And I mean, there's not much to see here actually, but just so you know, it's in real time here. So again, recording in 4K video, and let me turn that off real quick. And so we've got the CPU load, you can see, is pretty heavy right here. And this isn't going to matter on the TinyFSK, right? It'll be more interesting when we get to the USB FTDI serial port. That's what everybody really wants to see. So I'll turn the scope back on. I think that's big enough, definitely. And I'll come over, and if I didn't forget anything, what I'll do is I'm going to just, on the keyboard down here, I'll start the diddle by sending the square left bracket down again, the Arduino has a built-in USB serial port too, which is FTDI, and so, but the only thing I'm sending to the Arduino is a character that I type on the keyboard. So as soon as I click that left square bracket, that's going to kick the Arduino TinyFSK code into the diddle. So, which I just did, and I wanted to come down here to a small, so I clear so we got a nice trigger centered here, and you can see at the top the mega samples per second, and I don't know if this is going to show it much, but I mean, you'll be able to see this at the top. I just wanted to point that out. So as you would expect, right now I've got the width, the horizontal width is at 10 milliseconds, so every segment on the scope is 10 milliseconds, so hence you're going to see 2 segments plus 2 milliseconds there. So you know, if I move that to the right and line it up right, you're obviously going to see 22 milliseconds there. Let me clear that too. And right now, if I go down a little smaller, the Arduino is putting out a nice solid 22 millisecond diddle in effect, right? And anything I do on the PC and all this CPU activity that's going doesn't impact the CPU on the Arduino. It's dedicated to that timing, and so you get that precise 22 millisecond timing. Now we can zoom in a little bit. I should mention that the scope does not have an external reference, but it seems to be pretty accurate here. There's certainly more expensive scopes out there, but it's amazing what you can get these days. If I increase narrow the horizontal per segment timings down to, here, let's get down to 2 milliseconds. So now, right, you've got 10 segments plus 2 more milliseconds. So, but I'm just using the width of the scope there for the trigger, and we'll clear the stats there. So you're going to see right now kind of the jitter with TinyFSK. And so based upon this particular scope, the average you can see there, again the yellow, the average is 21.95 milliseconds. And you can see there's a little bit of jitter based on the current there. See, it's jittering 40 microseconds, so 4 milliseconds, right, either way. So you've got like a peak to peak of 4 milliseconds or 40 microseconds off of 22 milliseconds, or in this case the average is 21.95. I can reset it again, right? The minimum isn't going below 21.94. The maximum is not going above 21.98 based upon this scope, and it seems to be pretty accurate. So we bring that in, reset the stats there again, and at that 10 millisecond per horizontal segment with 50 megasamples per second, it's not quite as accurate, but for what we're dealing with in amateur radio here, this is very precise, right? So that signal timing is very, very good. And I could right now, I could kick this into, well, let me turn it off here. So I'm going to come back over to here, right where the mouse is, and I'm going to turn off the diddle here with the right square bracket. If you've read up on TinyFSK, you'll know how that works. You set up your software to send those characters down. And then I clear the sample we've got going there. And let's give, with all the CPU activity, now it's going to be very interesting to see what we get with that 8-port FTDI USB 2.0 serial port that is hooked up to the second channel, or the second probe here, and we'll do the same thing. Now this sample and this probe is the lower one, so it's blue on the bottom there, so you're going to see the same exact data except lower on the scope. And so I need to turn off channel 1 here, turn on channel 2, and I'm going to go over to the trigger, change this source to channel 2, and in N1MM I've got, let's see here, let me just bring this over in N1MM. I mean, I could use the keys inside N1M, but I'm just going to use the RTTY engine as displayed here in N1MM. I guess I could turn on the XY scope. And let's see if I can, let's see. I want to keep that scope big on the screen, the oscilloscope, right, this window here. I want to keep this fairly big. I need to make it a little bit bigger. And I'm going to turn that off again to take a good look at the CPU right now. So here we've got the CPU is still hovering around 40%, 43% across those 6 physical cores. The logical cores, you get the 12 cores, so that's what you're seeing on the screen here. And it's in boost mode right now. Based upon the temperature of the CPU, the cores are running at 4.3 gigahertz. That's stock Intel stuff. So here is where the CPU will impact, right? This is a Windows 64-bit, latest and greatest, you know, whatever the consumer grade Windows 64-bit Pro is, preemptive operating system, and you've got that Intel CPU. Excuse me, I said preemptive. It's non-preemptive, right? So one process can't preempt another process, and that's the dilemma, right? You start doing timing. It's tough to do precision timing and guarantee that timing for a single thread when other processes and the scheduler at the CPU and OS layer can interrupt that thread and potentially impact your timing. So not to belabor that, but here's the CPU. I'm going to make that small again. We'll get it up here because you should see one of the threads go higher because of the way external FSK 64-bit operates is, let me put that up here. This is not rehearsed very well here, guys. I'm just going to drop that right there. Get that scope turned back on. The oscilloscope. There we go. Okay, I think we're ready to roll here. So as soon as I hit transmit here, obviously we're not keying the radio. The PTT isn't hooked up or anything, and you're not going to hear the diddle, but you'll see the visual representation here of the diddle going on, and we should capture that trace. So I'm going to hit transmit, and boom, there's the trace. And I'll let you guys come to the same conclusion that I've come to. So now we're, even with all of the CPU activity going on right here with OBS Studio recording in 30 frames per second, 4K, as you can see at the top of the scope window there, it's at 50 megasamples per second. We're rock solid at 22 milliseconds based upon the accuracy of this particular scope. So I can clear the stats there and get a clean sample. Again, right, if I load up another program, if I were to start I mean on a browser, you know, I can come over here, get a browser window open, go check my email. You saw some jitter there, right? Right there. You saw a little bit of jitter happen right there when I opened up the browser. But consider how much activity is going on, right? Let me do that again. So there's a browser open. So there was some jitter on the 22 milliseconds. But now you don't see that. Let me open up a different browser. There was a teeny tiny bit. The max just kicked up to 22.2 milliseconds there. Opening it up Chrome. And if I go back to IE, it did it again there. Reset it. I'm going to stop the diddle there, clear it, and I'm going to start it up this time with just the Alt-T inside N1MM, and I literally have not tried this before, so I'm just going to do Alt-T, get the diddle again. I'm doing stuff in N1MM. I'm looking up call signs, G7M. If I go to the config and I rescore the current contest, you're not seeing any change, right? We're sampling that 22 milliseconds. So my experience has been it's very unusual to see any changes, and if there are any changes, it's less than a millisecond on any jitter there, even under this heavy load. Now, if I wasn't running OBS Studio, I don't think you'd see anything at all. I mean, you can see it just isn't changing. So let's go back to the CPU here, and what's interesting too is you really don't see a high CPU, and the scheduler might be managing some of that. So I'm going to make this smaller. So we're still sampling the COM port. We're still at 22 milliseconds at 50 megasamples per second on the scope, and I just wanted to zoom in and show you the CPU load here is quite high. As you can see, this is very high for compared to what I would be doing in a real contest. So we'll get back out of here. Now let's zoom in and see if we have similar numbers to what we were seeing with TinyFSK. Coming back up here, we'll make this big again. Alright. So we did get a hair jitter right there. You got 0.2 milliseconds, so 200 microseconds. The max went up there during the time I was doing that. So I'll reset the sample. If we come up to a 250 megasample per second resolution here on the scope, you can see the average is pinned right to 22 milliseconds, and we're bouncing around very similar to TinyFSK with the dedicated CPU doing the timing at, again, 40 microseconds or 2 milliseconds either direction, right? So your peak to peak is 4 milliseconds. So now if I open up a browser again, let's see what happens. So you saw a max jump up there to 0.06, so it jumped up 0.0 microseconds when I started doing that. But again, in a real world contest situation, you're not going to have this much CPU load on the CPU. So clear that out. If I stop the transmit, let's see. Stopped it, clear the trace. I'm in N1MM, start it up again. Clear the trace and resample. There you have it. If I go back down to 50 megasamples per second, it's pinned right to 22 milliseconds. So with that, let me stop the diddle there on MMTTY, clear it. What I'm going to do now is I have, in that second segment where I showed the hardware, I have an older 5 or 6 year old, I mean it was a high-end laptop at the time. It's a Asus i7, the mobile version of the i7, running at 2 gigahertz, and it has an FTDI, just a single FTDI serial port connected to it. And I think it's the FTDI serial port that L-Craft actually sells. The long, it's like a 10-foot black FTDI cable. And so I've got that hooked up. I just wanted to show that because that's a little more real world as far as the, you know, you don't have this high-end 6-core CPU over here. You're going to have 4 physical cores, 8 logical threads. And I don't have a camera on that box, but I'm going to change the serial port here. So I'm going to, that beige serial port I showed you coming out of the VSCOM card, I'm pulling the header out of that, plugging it in now to the serial port that's coming off that laptop. And I mean, I'm just, I need another camera here ideally. So let me clear the sampling that's going on there. And I'm going to make this bigger for now. And I'm actually going to make you guys sick. I'm going to take this over here. So over here, right, I'm going to fire up MMTTY, which, well, this is, you just got to trust me here, I guess. So I'm going directly to MMTTY, fire that up. Okay, so I'm on COM 3 here. You're not going to be able to see that screen, but I'll pull up the processing. And so the performance here, CPU performance, you're not going to see this very well, but you've got the 4 physical processors, 8 logical threads, and MMTTY uses a little CPU right here. So we're at, it's actually using quite a bit here. It's using, you know, 20% on this machine. So back to MMTTY. I'm going to put the video back on for you guys, you know. About lose it there. So we'll zoom back out here, get rid of me, and I'm going to reach over and on the mouse, I'm going to start transmitting now. And if I've got everything the same, so now we're going to see a little more real world computer, how it's going to look on the Diddle here. There we go. So that's coming off the laptop. It's pinned right out of the gate to 22 milliseconds. And I didn't figure there was any reason to do the TinyFSK off the laptop because, I mean, it's that dedicated CPU there. So here, now if I start up a browser, and I haven't tried that, so I'm going to start up, so we're monitoring there at 50 mega samples per second. If I just fire up like Chrome, so there's a little bit of jitter there. You saw once Chrome came up, right, there's some, it has an SSD in there, so you saw some jitter there when the CPU did something. I reset it there. Now let's pull Chrome up again. And you see it again. So it's a little bit more involved. If you're doing a lot of other intensive tasks, you might see some jitter, but it's still quite low. So if we go to something like Microsoft Edge, pull that up. Let's see here. And I'm not seeing any change there with Microsoft Edge. Loading up. So sometimes when there's some disk activity, you might get literally a split second of some jitter there that obviously wouldn't show up with TinyFSK. Let me start up N1MM. That might be interesting. So I'm going to fire up N1MM, and I know you can't see the screen, but let's see. Come on. There, N1MM is starting up. And it's complaining because I don't have a bunch of stuff hooked up to it. And so it just fired up. It actually just loaded up. I'd never loaded N1MM up before. It didn't touch. Everything's clean as a whistle, 22 milliseconds. So if we zoom in like we did on the high-end PC down to 250 megasamples per second, you can see it's very similar to what it was before. Let me clear the stats there. So here you're bouncing, the average is, I mean, for all intents and purposes, it's still at 22 milliseconds. And we're bouncing here, it looks like around 4/100ths of a millisecond. I think I was saying milliseconds before. It's 4/100ths of a millisecond, or 40 microseconds. Looks like sometimes this one is bouncing 6/100ths of a millisecond to 60 microseconds. So I think I did say milliseconds earlier. Yeah, we're talking hundredths of milliseconds here, guys. So even when I started Chrome up, right, we're talking hundredths of a millisecond. So come to your own conclusions here, but if you're concerned about timings on the right PC, multi-core PC, with MMTTY and external FSK, I think you're good to go with external FSK64 or something like TinyFSK or another external solution as far as the CPU is concerned. Oh, back to the camera here. I'm looking at the scope, so I don't know what else to demo here. I mean, I could, for kicks and giggles, I could stop MMTTY here and kick it into, I have not tried this yet, kick it into 75 baud. Let's just see what that looks like. So bear with me. Let's see, baud rate 75. Okay, I'm going to kick on, I'm going to clear the sample. On the screen there, you saw that. And we're going to kick it into transmit again. Oh, there you go. So I think that's spot on for 75 baud. So here, right, you're seeing, I'm looking at the scope, so you're not going to see me. So you're seeing 13.4 milliseconds. If we cruise in, right, I'm not going to recenter there because we'll lose the width measurement there as soon as I get off the screen. I could do cursors, but I'm not going to mess with that. So you see a little bit of jitter once you get out to, well, I guess we're down to because it's not as wide there, we're down to the 250 mega samples per second. So we're getting a, you know, it's all relative, right? What we're calling jitter here, we're calling, you know, hundredths of a microsecond jitter going on here. And the way that translates over the air through the, you know, as our signals refract off the ionosphere and the Earth, it's pretty tough to measure that. So you're seeing a little teeny tiny bit of jitter, but let's go back to TinyFSK. So I'm going to, you know, go all the way here, 75 baud on TinyFSK. We're going to go back to turn off channel 2 here. And I've got channel 1 sample back on. I got to set the trigger back to channel 1. Okay. All right, back to the computer here. Make this a little smaller. I'll just you can watch me change to 75 baud. Excuse me, on the terminal here in TinyFSK. So TinyFSK. I do a shift tilde to, shift tilde to get into the configuration command. And so I'm going to hit a 7 here. That's going to kick it into, the speed now is 75 baud. And so if I kick it on here, we should see a sample now. Let me go back big on that screen. So here again, dedicated CPU. And we should see the diddle at the top there. I can't remember. We got the let's go back to 10 microseconds per horizontal unit there. And I'm going to start the diddle on TinyFSK. There we go. And let me clear it. And there you have it at 50 mega samples per second. It's stuck exactly like external FSK64 was, 13.4 milliseconds. And if I zoom in, clear it there, at the hundredth of a millisecond, or tenths of microseconds. I haven't done this either. There literally is no jitter there that the scope is measuring, it appears. Let me center this, and I should be able to go out a little more. Let's see if I can get to 500 megacycles per second. It's going to go off the screen, and we'll lose the we'll lose the trigger. So that's nice and clean there at 75 baud, which is rare, right? I think I've done one contest at 75 baud. So I'm going to change this back to 45 baud. Let's see. 45.45. And clear it. So now you're back. There we go. Oops. And we're really at the overkill level at this point, I think. Back out to 250 megasamples per second. And at 45.45 baud, the jitter on the scope here is the same between the two. Alright guys, I think that's enough. I'll get this video out there, and everybody can come to their own conclusion, and hopefully it'll generate some discussion, and if you like the video, like it and make objective comments. That's great. And things have changed. It's 2018. CPUs, multi-core CPUs are the rather than going faster, we do multiple cores, and so that gives a comparison to what's been done in the past. Thanks for watching, and maybe I'll come up and dream up some other idea to do another video with. Alright, 73 for now, guys.